Hi everyone, and welcome to this Kotlin course for Java programmers. We've seen already how the language allows for a primary constructor, one or multiple init blocks, and secondary constructors. Today, we're going to talking about inheritance, secondary constructors, data class, and null point exception. Let's get started. First example. Okay, so here I'm declaring the first class pizza. I'm also using this keyword over here, open. Why? Well, because in Kotlin, all classes are final by default. Use open to enable subclassing. Because down here, I have this other class pizza special crust, which is actually using pizza as a base class, right? Now, what happens if I remove this open over here, right? And then if I try to build this application, I'm going to get an error. I'm going to get an error because I won't be able to use pizza as a base class. 1, 2, 3, and it is. Right? Let's fix it. Okay. So this class has the pizza name as a string, topping name as a string, and then this is the first init block, and then I have my second init block. And also I have a method over here, or function if you wish. And here, the pizza special crust class is going to override this function. So I need to use open as well as here for the same reason. Now I have my third init block and a secondary constructor. The secondary constructor for the pizza class is going to delegate to the primary constructor of the pizza class itself, and that's the signature, and that's the delegation to this, and then is going to execute additional code. Over here, the constructor for the pizza special crust is going to delegate to the primary of the base class, see, super, and then is going to execute additional code. Let's have a look at the main function. So we have a pizza1, which is a pizza, and then we have a pizza2, which is still a pizza. But then see, we are calling two different constructors. So this will not call the secondary constructor. Why? Well, look at the signature, right? They don't match. And then this one is going to call the secondary constructor because look at the signature here, right? Don't forget that the secondary constructor anyway is going to delegate, right? And here, the last object is a pizza special crust, which is again going to delegate to the primary constructor of the pizza class. Before we build and run this application, I want you to focus on these prints over here. Each one of these is going to telling you which part of the code is being executed. So here we see that we are running the third init block. Here we are running the secondary constructor. Here we are running the constructor of the extended class. Okay, so we build the application. And then we're including the runtime, okay? And then we run the jar. Okay, so as you can see, we are running the 3 blocks. And then here, we're running the 3 blocks as well. And also we're running the secondary constructor. And here, in the extended class, we are running the 3 blocks again, plus the extended constructor. We are not running this one, right? Although, see, the signature are the same, but that's a different class, right? So we're going to be running this, running this. And I think for this topic will be enough. And so let's move on. Another thing that I want to show you is that in Kotlin, you can extend any class even though you're not inheriting anything from it. Here, for example, we have these two classes, pasta and order. Order is actually adding new function to the pasta class, even though pasta is not the base class of order, right? There is no inheritance at all going on between these two classes. Even though there is no inheritance, I'm able to add a new function, which is called cook, and then I just created myself an additional function that is going to be calling this one, passing a pasta object. Let's see what happens when we build and run this code. I've built already the code for you. Let's run it. Okay, pasta is ready. Let's have a look at the code again. Okay, so it was able to execute the function that I created, that I've just extended from the pasta class, although there was no inheritance going on at all. Let's move on. In Kotlin, like in many other languages, you can create classes that only work as a data storage. The only thing you need to do to declare a data class is prepending this data keyword over here. Now, I created my data class, pizza order, with my two data fields, order ID and pizza. Now in here, in main, I'm creating two objects, order 1 and order 2. Order 2 is a copy of order 1, although the pizza name is going to be different. These two objects, though, they are going to be sharing the order ID because order 2 is a copy of order 1. And this is something I really wanted to show you, how easy it is with Kotlin to create copy of data class or data object. Let's see what happens when we run the code. I've already built it for you. Okay, so object 1 is going to have order ID 1 and pepperoni, and object 2 is going to have order ID 1 again because it's a copy, but the description is going to be simply cheese. So it worked as expected. And now let's move to the next topic, which is also going to be the last one for this class. And the last topic for this class is NullPointerException. In Kotlin, a NullPointerException might happen only because of explicit throw, usage of this operator over here, which throws NullPointerException if the test returns null, and serialization issues, and external Java code, which also happens to be throwing NullPointerException. Now, in Kotlin, we have two types of objects. Objects that do accept null values, and you declare this kind of object by appending the question mark right after the data type, and objects that do not accept null values, which is the default over here. Now, if we have a look at this example over here, if I were to remove the comments in here, I will find that this line over here will combine fine because we are putting pizza equal to null And this, as you can see, is a nullable type. But when you try to have order ID equal to null, then this won't compile because this is a not nullable object. Let's see what happens when we try to compile. We are going to get an error. So in this case, the compiler is smart enough to tell us you can't do that because order ID is by definition not nullable. So your code won't even compile. I hope you've enjoyed this class and thank you very much.